Hello everyone, hello teacher. We are group 4 and today we are honored to present topic 6, description of the manufacturing process of tablet. In this presentation, we will walk you through the advanced technologies used in modern pharmaceutical production. Here in our team, each member has focused on a specific stage of the process. Our presentation is structured into 4 main sections. Part 1 is overview and ingredient preparation. Part 2 is main production process. Part 3 is post-compression and packaging. And Part 4 is technical standard and quality control.
Part 1. Overview and ingredient preparation. One by one, overview of tablet. What is a tablet? A tablet is a solid dosage form that complete active ingredient and excipient compressed into units with specific shape, weight, and strength for effective pharmaceutical delivery. Classification of tablet: conventional tablet, coated tablet, film-coated tablet, sugar-coated tablet, chewable tablet, evaporation tablet, modified release tablet, extended release, controlled release. Advantage of tablet: accurate stasis, stable, easy to store, easy to transport, and suitable for large-scale production. Can make mass unpleasant taste and protect active ingredient by coating. Disadvantage of tablet: difficult for children and elderly to administer effectively, not suitable for active ingredients, sensitive to compression forces, bioavailability varies due to disintegration and dissolution rate. 1 by 2 tablet formulation component: active pharmaceutical ingredient by APE, the component responsible for graphic effect. Requirement: purity, stability, and suitability for compression method. Excipient in tablet: excipient group diluent. Function: provide tablet grade. Example: lactose, avicel. Excipient group binder. Function: create binding between pastille. Example: PVP, Starpet. Excipient group disintegrant. Function: help tablet disintegrate rapidly. Example: Stacro, Scambulosa. Excipient group lubricant. Function: reduce freezing during compression. Example: magnesium stearate. Excipient group Glidden. Function: improve powder flow. 1.3 Preparation of tablet material. Raw material inspection. Organoleptic properties: color, odor, normal, appearance normal, no agglomeration, moisture content, which is allowable limit to avoid powder agglomeration or friable tablet. Particle size appropriate and relatively uniform to ensure good flow and mixing. Pharmacopoeia standard meet quality specification before manufacturing. Weighing and dosing: weigh according to the formula with correct ratio of active ingredient and excipient allowable derivation to ensure content uniformity. Part correct must be fully documented for control and structurability. Sieving: ensure uniform particle size and reduce segregation. Remove agglomerate and solution powder. Improve mixing and compressibility. Handling tablet quality.
Next, I would like to present about main production process, granule formation stage. First, let's consider the purpose of the granulation stage. The purpose of the granulation stage includes improving the flowability of the powder mass. It also includes increasing the uniformity of the active pharmaceutical ingredient. In addition, facilitating of the tablet compression process and ensuring the quality of tablets. Next, let's move on to granulation methods. Part A is a wet granulation, most common. 1. Mixing the active ingredient and excipients. 2. Adding a binder solution to form a wet mass. 3. Passing through a sieve to form granules. And 4. Drying and sizing the granules. Advantages: strong granules and easy tablet compression. Part B is the dry granulation, which includes: first, mixing the two powder components, next pressing into case or slabs, then milling, sieving to form granules, suitable for moisture-sensitive drugs. This slide shows the process flow diagram. There are 5 steps. First, mixing the powder blend. Next, forming a wet mash. Then granulation. Next, drying. And finally, sizing. Next, let's learn about the equipment used in the granulation stage. This is a high-shear mixer and that's a granulator. This image shows fluidized bed dryer and integrated mixing granulation drying machine. Now we move to part 3, post-compression and packaging. This stage is crucial because it transforms the granules into the final tablet form that patient actually use. We will cover 3 main processes: tablet technique, film coating, and finally packaging. So first, let's look at tablet technique. To form a tablet, we use either a single punch or a rotary tablet press. The single punch press, also known as an eccentric press, follows a 3-step cycle. Feeding, or you can call filling, the formulation material are loaded into the die cavity. Compression, the upper punch moves down to compress the powder into a solid tablet. Ejection, finally, the finished tablet is pushed out of the die. This machine is usually used for small-scale production or R&D. For large-scale industrial manufacturing, we use the rotary tablet press or multi-station press. The cycle here is more continuous and complex, involving material feeding and weight adjustment to ensure dosage precision. Then it goes through pre-compression and main compression to ensure the tablet has the right hardness. And it's like the single punch, it ends with the ejection of the tablets. Once the tablet core formed, we often apply a thin polymer layer in a process called film coating. So why do we do this? There are 4 main objectives. First is protection, to shield the drug from environmental factors like moisture and oxidation. Second is modify release, to control how and when the drug is released in the body. 3 is taste masking, to hide any unpleasant odors or the bitter taste of the active ingredients. 4 is aesthetic and identification, to help patients easily distinguish between medications to different color or imprints. Now let's look closer at the 4 steps of film coating technique. So for the step 1, it is formulation and preparation. And ingredients, we use HPMC or PEG. Modern approach use a pre-formulated premix for the better consistency and time saving. For the process, mixing ingredients into the solvent using a high-shear mixer to achieve a homogeneous suspension without air bubbles. Second, for the step 2, it is spraying phase. This is the heart of the process where the liquid is atomized into fine mist. And equipment using a perforated coating pan and spray gun. We must control the spray rate carefully to avoid overwetting. Third, the drying phase. Hot air is used in evaporate the solvent. A perfect balance between spraying and drying is essential for a smooth surface. And finally, for the step 4, it is quality control finishing. For the cooling, tablets are cooled down slowly to prevent sticking. Visual inspection, checking for surface smoothness, color uniformity, and glossiness. Defect prevention, ensuring no common errors like picking, pitting, or orange peel. Now we move on to the final step called packaging, which protects the finished product before it reaches the market. So for the blister packaging, we have 2 common types. For the first, it is aluminum blister. So as you can see, both the base and lid are aluminum. This provides an absolute barrier against moisture, oxygen, and light, making it ideal for highly sensitive drugs. And another blister called aluminum plastic blister. This uses a transparent plastic base and an aluminum lid. It cost effective and allows patients to see the tablet clearly. Lastly, we have bottling. We typically use HDPE plastic or glass bottles. You will often find a desiccant inside to absorb moisture. This method is perfect for pill quantities or medications that require multiple doses after the container is opened.
Part 4. Technical standard and quality control. This slide talks about the purpose of quality control, also called QC in pharmaceutical production. First of all, QC ensures that the product follows pharmacopoeia standard. This means the medicine must meet physical quality requirements before it can be used. Secondly, QC helps guarantee safety, efficacy, and uniformity. In simple words, the drug must be safe for patient, work as expected, and have the same quality in every batch. In addition, QC controls the quality of the finished product before the product is released. Test and carry out check it in identity, strength, and purity. Finally, quality control is a mandatory regulatory requirement. If a product does not pass QC test, it cannot be legally distributed on the market. The final step in the pharmaceutical manufacturing process is quality evaluation. At this step, we check whether the finished tablet meets quality standards. First, we have uniformity of mark. This step checks if all tablets have similar weight. If tablet weight is consistent, patient receives the correct dose. Next is uniform of content. This step focuses on the amount of active ingredient in each tablet. It is especially important for low-dose drugs. The desired reason check how fast the tablet breaks down. This is important because the drug must be released properly in the body. After that, we move on the test related to tablet strength. The hardness test checks how strong the tablet is. Tablets should not be too soft or too hard. Good hardness helps the tablet stay intact but still dissolve well. The friability test checks whether tablets lose weight during handling. This simulates transportation conditions. Acceptable weight loss should be less than 1%. This dissolution test shows how the drug is released from the tablet. This test helps us understand how the drug may behave in the body. Lastly, we have the acid test. This test measures the extract amount of active ingredient in the tablet. Methods such as UV visible spectrophotometry and HPLC are commonly used. The results must match the label gram, usually between 95 and 105%. This test is very important to ensure both drug quality and patient safety. Conclusion: manufacturing excellence, understanding the structure and principle of tablet press and film coating machine is crucial for ensuring medicine quality and stability. Technological integration, modern packing equipment play a vital role in protecting pharmaceutical products from the environmental factor. Final outlook: mastering the technology allows pharmacy students to better adapt to industrial production environment in the future. NCT Revolution. Thanks for listening.